Bismillahirrahmanirrahim. Assalamu alaikum dear students. This is your instructor Anisa Nawaz from Department of Physics. This is our lecture number 19 from chapter number 2, Vectors and Equilibrium. In the previous lecture, we have discussed about characteristics of cross product and difference between dot and cross product. And in this lecture, we will discuss about some numerical problems related to dot and cross product of vectors. Okay, so we will just discuss examples and assignments related to dot and cross product, and we will discuss numerical problems related to dot product and cross product as well. Okay, so let's move to the first example, example 2.4 in your book. The statement of example 2.4 is a vector A having magnitude 3.2 makes 50 degrees with x-axis, and vector B with magnitude 5.2 makes 110 degrees with x-axis. What is the magnitude of their dot and cross product? So what is the given data? You can see over here we are having a vector A and its magnitude is 3.2 without any unit. Okay, vector A 3.2 makes 50 degrees with x-axis. It is making an angle of 50 degrees. And vector B with magnitude 5.2 makes 110 degrees with x-axis. This is the given data, and we have to find out the magnitude of their dot and cross product. Okay, we have to just find out their magnitude, not complete value. Okay, we just have to find out the magnitude of dot and cross product. So we will follow the same format as we have done in the previous numericals. That first we will write down the given data. We have given data of vector A, its magnitude. You know that the representation of magnitude is either in this form, bars with arrowhead, or simply A. Both are representing the magnitude, and the given value of magnitude is 3.2. Theta, angle theta 1 is 50 degrees with x-axis. Vector B, magnitude of vector B is 5.1. Angle theta 2 is equal to 110 degrees with x-axis. Okay, that was the given data. Now what is required value? We have to find out A dot B, magnitude of A dot B. That's why we are putting these bar signs over here. Magnitude of A dot B, we have to calculate this. Then magnitude of A cross B, we have to find out the magnitude of A cross B. These two magnitudes are unknown. Okay, we are not going to find out the direction of A cross B, we just have to find out its magnitude. That's why we are putting this sign. Okay, so if we are going to start solution, first we have to draw the figure according to the given data. We will draw the coordinate axis, x and y axis. Okay, so it is given that we are having first vector A, which is making an angle of 50 degrees with x-axis. Okay, and we are having a vector B, which is making an angle of 110 degrees with x-axis. You can see we are starting the angle from positive x-axis, so it is making an angle of 110 degrees with positive x-axis. So these two are the given data. Okay, and we have to find out the magnitude of dot and cross product. We have to find out the magnitude of dot and cross product. We know that while multiplying the vectors, the first step is to join the vectors from their tips. We have to join the vectors from their tips. We have done this thing. Okay, and then theta, which we have to calculate, which we have to put in the formula, is the angle between these two vectors. It is always smaller of the angle between these two vectors. So if we are having these two vectors, vector A and vector B, you can see over here one angle is this and the other angle is this whole angle. But what is happening over here, our requirement is this smaller angle, smaller of the two angles between vectors A and vector B. Okay, you can see this theta is basically this angle 110 degrees. You can see over here 110 degrees minus 50 degrees will give us this theta. Okay, if we are subtracting this angle from this whole angle, then we will get this value of theta 110 degrees minus 50 degrees, that is giving us 60 degrees. Okay, this is that value of theta which will we will put in the formula of A dot B and A cross B. So what we have done, we have drawn the two vectors according to the given data, vector A and vector B, vector A at 50 degrees, vector B at 110 degrees. Then we have calculated the angle between the two vectors. Okay, now we will simply put the values in the formula. You can see over here, the required angle for dot and cross product is the smaller of the angle between two vectors, which we have already calculated, theta. From figure we have theta is equal to theta 2 minus theta 1. Okay, we are subtracting smaller angle from the bigger one. 110 degrees minus 50 degrees, that will give us 60 degrees. So we have theta is equal to 60 degrees. Okay, after that what we will do, we know that the magnitude of dot product is, we will solve the first part. We know according to the formula A dot B is equal to AB cos of theta. Okay, so this equation 2 is basically giving us the magnitude of dot product. Okay, then what we will do, we will put the values in equation 2. Magnitude of A is given, magnitude of B is given, and we have calculated the value of theta. So we will put all these values over here. 3.2 multiplied by 5.1 into cos of 60 degrees. Okay, so we will get this 8.2. This is the magnitude of dot product. That's very simple. We will simply put the formula, we will put the values in that formula, and we will find out the answer. 8.2 is the required magnitude of dot product. Okay, then we have to calculate the magnitude of cross product. The magnitude of cross product is A cross B is equal to AB sine of theta. You can see over here we haven't put n hat. Why? Because n hat is telling us about the direction of cross product, which is not required over here. In question they have just asked about magnitude of cross product. Okay, so you can see if over here magnitude of cross product is equal to AB sine of angle between them. Okay, so we are not putting n hat over here, that is not required, just magnitude is required. So simply we will again put values in equation number 3, magnitude of A, magnitude of B, and sine of angle between the two. So what will be the result? 14.1. This is the magnitude of cross product. Okay, simple numerical. What we have done, according to the given data, we have calculated angle between the two vectors, then we have calculated magnitude of dot product by putting the formula, and then we have calculated the magnitude of cross product by putting the values in the formula. Okay, so if we move to assignment 2.4, which is given in your book, statement, you can see in your book it is given that show that A dot B whole square plus A cross B whole square is equal to A square B square. They have used bracket in your book, they have used bracket. It should not be bracket, it should be these bar symbols, because it is the magnitude of A dot B and magnitude of A cross B. Okay, magnitude of A dot B whole square plus magnitude of A cross B whole square is equal to A square B square. You have to make this correction. They have used parenthesis, they have used brackets, so you have to change that brackets to this magnitude symbol. So what we have to prove, we have to prove this thing, that magnitude of A dot B square plus magnitude of A cross B square is equal to A square B square. So what we will do, we will simply find out magnitude of A dot B, then we will take square of that, then we will find out magnitude of A cross B and square of that, then we will add two values. Let's see how we are going to do that. The magnitude of dot product, we know that it is A dot B is equal to AB cos of theta. Squaring both sides, what we will get? We will get A dot B whole square is equal to AB cos of theta whole square. You can see we are squaring both sides, so A dot B square is equal to A square B square cos theta whole square. So we will apply this square on all of these terms. That will give us A square B square and cos square theta. Keep this in mind. We will not write it as cos theta square, that will be incorrect. We have to write it as cos square theta. That is the correct form of writing square of trigonometric functions. So what is there? We are having a square b square cos square theta. Okay, name it as equation number 3. We have calculated square of the magnitude of dot product. Now what we will do, the magnitude of cross product is a cross b is equal to ab sine of theta. Again, only magnitude is required, that's why we are not putting n hat over here. Direction is not required because only magnitude is required over here. So magnitude of a cross b is equal to ab sine of theta. Then as we need the square of this term, so by squaring both sides of equation 4, we get a cross b whole square is equal to ab sine theta square. Then again applying square on this term, we will get a square b square sine square theta. Now in the next step, what we have to do, we need sum of these two terms. We have to add these two terms. Okay, so left hand side will be added in left hand side and right hand side will be added in right hand side. So by adding this equation 3 in equation number 5, what we will get, let's see. We have adding equation 3 and equation 5, we get a dot b whole square plus a cross b whole square is equal to a square b square cos square theta plus a square b square sine square theta. Okay, we have added left hand side into left hand side and right hand side into right hand side. You can see that on this right hand side, a square b square is a common factor, so we can take it as common. Okay, a square b square, and within the brackets we are having cos square theta plus sine square theta. And you people know this thing very well, that this is our trigonometric identity. Cos square theta plus sine square theta, it is giving us the value of 1. Okay, so what we will do, as we know from trigonometry, cos square theta plus sine square theta is equal to 1. So putting values, that will give us a square b square into 1. Okay, so what is the result? A dot b whole square plus a cross b whole square is equal to, and magnitude of these two, okay, is equal to a square b square. This was the required answer. So hence prove this thing. Left hand side is equal to right hand side. We have proved this given identity. So if you are having any proof, then what you will do, you will take left hand side or right hand side, one side which it is having a capacity of solution, okay, which is having a capacity of solving. So you will just put the values, you will solve it, and you will get the result. That's very simple. You should just know the formula of a dot b and a cross b. Okay, you should have a difference between the magnitude of the terms and direction of the terms. You should know this thing, that when we are going to put the magnitude and when we are putting going to put the complete formula. Okay, so numerical question from your exercise, numerical question 5. It is again related to dot and cross product. So let us solve it over here. Statement is vector f having magnitude 5.5 Newton makes 10 degrees with x-axis, and vector r with magnitude 4.3 meters makes 80 degrees with x-axis. What is the magnitude of their dot and cross product? It is exactly similar to that of example which we have already done. Okay, we are having two vectors, their angle and magnitude is given, and we have to calculate their dot and cross product. Okay, we will follow the same format of solving the numerical. Given data, vector f, it is equal to, magnitude of f is given as 5.5 newtons. Angle, it is making an angle of 10 degrees with x-axis, this is again given. Then vector r, it is having a magnitude of 4.3 meters and angle theta 2 is 80 degrees with x-axis. Okay, theta 1 is 10 degrees and theta 2 is 80 degrees. So what is the unknown value? we have to find out their dot product, so we will write it as f dot r, and we just have to calculate their magnitude. That's why we are putting this symbol. Okay, magnitude of f dot r, dot product, and magnitude of the cross product. Okay, again we are putting this symbol for magnitude. So this is the magnitude of cross product. Okay, we have to calculate these two values if we are going to start the solution. So first we will draw the figure, we will draw the coordinate axis, x and y axis, and then we will draw the given vectors according to the given data. So we were having first vector f, which is acting at an angle of 10 degrees, and r, which is acting an angle of 80 degrees. Okay, you can see over here. So we are having f and r acting at 10 degrees and 80 degrees. Again we will follow the same procedure as they are joined from their tips. So we will find out the smaller of the angle between the two. These are two vectors which are to be multiplied, so we will calculate smaller of the angle between the two. Okay, this one, you can see that this one is the smaller of the two angles over here. One angle is this and the other is this whole angle. This one is bigger, so we need this smaller of the angle between the two vectors. So what we will do, we will find it out as theta is equal to 80 degrees minus 10 degrees, that is 70 degrees. So required value of theta is 70 degrees over here. Okay, so again same thing, the required angle for dot and cross product is the smaller of the angles between two vectors. From figure you can see this thing, that theta is equal to theta 2 minus theta 1, that is 80 degrees minus 10 degrees, that will give us 70 degrees. Okay, so we have calculated theta for these two vectors. So 70 degrees will be the required value of angle. Then we will solve first part. The magnitude of dot product is f dot r is equal to fr cos theta. Just a and b are replaced with f and r, nothing else. Okay, so f dot r, magnitude of f dot r is equal to fr cos of theta. Putting values in equation number 2, we have f dot r is equal to 5.5 newtons into 4.3 meters into cos of 70 degrees. Okay, over here we are putting the values with their units. So what is the value over here? 5.5 newton into 4.3 meters into 0.342, that will give us 8.09 or 8.1 newton meter. This is basically the magnitude of their dot product. Okay, first part is done. Then we will find out the magnitude of cross product. Magnitude of cross product of f and r is equal to fr sin theta. Putting values in equation number 4, what we will get? Magnitude of cross product of force and displacement is equal to 5.5 newton into 4.3 meters into sine of angle between the two, which is 70 degrees. Okay, after putting the values and doing the calculations, we will get 22.2 newton meters. This is the required magnitude of cross product. That was all for this numerical, because we just needed the magnitude of dot product and magnitude of cross product, which we have done. Okay, we have calculated magnitude of f dot r and we have calculated magnitude of f cross r. Okay, again repeating same thing, that if we are calculating magnitude of cross product, then we don't have to put n hat, but if complete formula of f cross r is required, then we have to put n hat. Okay, over here we just need the magnitude, so we will not write its unit vector, which is representing the direction. Is okay. So next, check out numerical problem. This is basically 6, numerical question 6. Okay, in your exercise numerical question 6, the magnitude of the dot and cross product of two vectors is 6 under root 3 and 6 respectively. Find the angle between the vectors. Okay, what is there? The magnitude of dot and cross product of two vectors is 6 under root 3 and 6 respectively. Okay, they have now provided the magnitude of dot and cross product, and we have to calculate the angle between the two vectors. Okay, this numerical is important because it is having you can say less of the given data, and it is most of the times it is repeated in exams. So this numerical is important, simple yet important. Okay, so first we will write down the given data. What is the given data? Magnitude of dot product and magnitude of cross product, and unknown is angle between the vectors. Okay, so we will write down the given data. A dot B, which is equal to 6 under root 3, magnitude of cross product, which is 6, and to find is angle between two vectors. What is the given data? Magnitude of dot product 6 under root 3, magnitude of cross product, which is 6, and angle between the two vectors is the unknown vector. Okay, so while starting the solution, the magnitude of dot product, again same repeated formula. A dot B is equal to AB cos of theta. Okay, the magnitude of cross product, AB sine of theta. We are simply putting the magnitude of dot and cross product because these two values are given. Okay, so what we will do, we will divide equation 2 by 1 because we need the angle and we don't have the magnitude of AB, we don't have the magnitude of either A or B. So what we will do, we will divide these two equations so that AB is cancelled with AB. Okay, we have to remove this AB. So what we will do for that purpose, we will divide equation 2 by equation 1. Okay, so left hand side will be divided by left hand side and right hand side will be divided by right hand side. So we have placed A cross B on the top and then cos theta, because we know that sine divided by cos will give us tan theta. Okay, so that's why for simplicity we have placed equation 2 over here in the numerator and equation 1 in the denominator. So left hand side with left hand side and right hand side with right hand side is divided. Magnitude of A cross B divided by magnitude of A dot B is equal to AB sine theta divided by AB cos of theta. Okay, then you know that AB can be cancelled out over here, so we will cancel this thing. AB is cancelled with AB and we are left with sine theta divided by cos theta, which is equal to the tan theta. So first what we will do, we know that according to given data we are having magnitude of A cross B and we are having magnitude of A dot B. So we will put these values. Okay, sine theta over cos theta. You can see over here, while putting these values, value of sine theta is 6 and value of A cross B, magnitude of A cross B is 6 and magnitude of A dot B is 6 under root 3. Okay, you can see this thing, sine theta divided by cos theta will give us 6 divided by 6 under root 3. So what will happen, this 6 will be cancelled with this. Okay, and we will be having value tan theta is equal to 1 divided by under root 3. Okay, tan theta is equal to 1 divided by under root 3 because sine theta divided by cos theta is equal to tan theta. We need the direction, we need theta, so we will separate it out from here. We will get value theta is equal to tan inverse of 1 under root 3. That will give us theta is equal to 30 degrees. This is the result. Okay, so if magnitude of dot and cross product is given, we can find out the angle between the two. Theta is equal to 30 degrees is the required answer. Okay, so I would like to end my lecture with this quote. Quaid-e-Azam's message to students: development is being sought in every walk of life and you have to take on this process of development. Are you preparing to take on tomorrow's responsibilities? Are you building your capacity? Are you trained enough? If no, then go and prepare yourself, because this is the time to prepare yourself for future responsibilities. Okay, so think about this message. This is for you people. This is the message to students that you have to prepare yourself, you have to train yourself for future. Okay, because this is the peak time, this is the high time to prepare yourself for your future responsibility. Okay, best of luck to all of you. Thank you so much. That was all for today's lecture.